desktop search for the simulation, and then you will get to this screen. You have to choose number 17 in this case.
What topic is this?
Topic number 9.
Okay.
Demonstrate the effect of physostigmine and atropine on acetylcholine-induced contraction of smooth muscle using simulation program. Actually, these things are quite similar if you get inside. So you have to choose the iliac strip. It means that ileum. So it's the bowel of the rat, or I don't know what kind of animal. But in this case, I know you never did, but you can read this theory. It's really short. Okay. Then you have to press 1 for the colors, and press 2 for micromolar. This is the way you have to add the concentration of each agent. Then you have to press screen S, and you will enter this good old screen. And what you have to show is that acetylcholine's action, actually, you know, you use different concentrations, but I think it's enough to show it with one concentration. And 0.1 micromole is what you have to remember. I tell you why. So at first I will use the acetylcholine, so I have to press 1. The concentration is 0.1. 0.1, it's better. You can see that the effect of acetylcholine is quite huge. And if you have to talk about the effects signaling. You know that there are a lot of kinds of cholinergic receptors, but the receptor which mediates the effect in this case is the muscarinic type of receptors. So you can block it with atropine. Atropine, exactly. So we have to then add atropine. 13 for atropine, and the concentration is just 0.05. You can see that atropine alone causes nothing, but since this time atropine is in use, okay, so it's not the effect of it, but then you can see here as well atropine in use in this concentration. Then we choose acetylcholine again, and we should add the same concentration.
So first we should add atropine and then on the
acetylcholine. Atropine and acetylcholine again, the same concentration. Why? Because the 0.1. In this case, the acetylcholine was used in the same concentration, but in the presence of atropine.
No.
And it completely blocked this effect. So it's really nice demonstration of the acetylcholine's effect was mediated through muscarinic receptors. Okay? It's the first part. It's really easy. You just have to remember these numbers. Shall I write it or do it something?
Number?
Okay, so or I think you have the video.
Yes.
Okay, so then you have to check demonstrate, this is the same topic, demonstrate the effect of physostigmine. What is physostigmine? It's also a blocker, but not for a receptor. It blocks an enzyme, the acetylcholine esterase. So actually, what acetylcholine esterase do?
Remove phosphate.
It degrades the acetylcholine. No, it's an enzyme which degrades acetylcholine by splitting it up to acetyl and choline. That's all. So if you block this enzyme, if you add acetylcholine the same concentration, it will act for a longer time. So your response should be higher. So actually you should do the same thing. At first we have to wash out in this case. Washout is 21. Because if you try to add immediately after this your agent, the physostigmine, it will alert you that you cannot use two antagonists, even if it's not a real antagonist. So we washed it out. Then we do the same thing. use acetylcholine at first to have something to compare to. Acetylcholine, 0.1. It causes the same contraction. Then use physostigmine 19, and the concentration is 0.5. As you can see, if you use it, it has no. Hello, watching. It has no real effect alone. But when we add the same concentration of acetylcholine again, in the presence of physostigmine, the peak of the contraction of acetylcholine is higher. So we demonstrated that in the presence of physostigmine, acetylcholine causes higher tension. That's all. Okay?
Yes.
Okay, the next topic.
So this one has finished, right?
Yeah, it was topic number 9.